Hello everyone, welcome back to my channel. So in today's video, we are going to talk about something which is super important in Kubernetes world called operators. So operator in Kubernetes is a method of packaging, deploying and managing a Kubernetes application. It extends the Kubernetes API with custom resource and automates complex application management tasks like it is kind of mimicking as a human operator, right? You can think it as a Kubernetes native automation for the application, right? Because if you have ever wondered how complex application like database or monitoring tools manages themselves inside a Kubernetes, then stick around because operators are the secret sauce behind that automation. Okay, so before we jump into the operator, let's summarize what we have discussed in our last video. In our last video, we have seen that what is the custom resource definition, because that is the way we can extend our API, we can extend the uh, roots of our Kubernetes which we want the way Kubernetes works, right? We can define our own resources, we can define our own APIs. So we have seen that if you want to extend your Kubernetes API, you can create your custom resource definition, and based on that CRDs, you can create your own CR, right? And in order to work that, we have understood that we need a custom controller which will keep an eye continuously on your custom resource whether they are running or not. Like we have few already inbuilt, we have pods, we have deployment, we have replica set. So all these things are already working, right? And whenever, let's say you have a deployment is there, and when you just try to delete any of the pod from that deployment, it will automatically get spinned up. So there is no black magic behind it. It is the controller, deployment controller, which will keep an eye on your resources, right? Like what you have desired and what you have current. So if it is not matching, then it will just suit that particular environment requirement and it will create your resources, right? So in the last video, we have seen how you can create your own CRD, and then basis on that we have understood, okay, if you need to create your CRD, then what is the schema, what is the version, what is the object you can define and all this. Let me take you to that. Okay, this was the file which we were doing. So we have seen that we can define our one of the versions of our API, and if you have multiple versions, then how you can serve multiple versions from the same CRD, how you can add it, and if you are trying to update your versions, right, then it will automatically migrate your old API versions to a new version which is already getting stored in your etcd. Then basis of this CRD, we have done our this small script which mylearn we were trying to do, and we have introduced a new property called message. If you have not seen up this CRD definition file explanation, then I strongly recommend go back and just show that video first. Okay, now let's come back to our operators basics, right? Because Kubernetes is a great at managing the workload which is a stateless in nature, like web servers or a simple API, right? Because there we don't need to do, it can just simply follow that manifest file and it will spin up your object, right? But the complex part is when you run a stateful application, right? Like PostgreSQL, Kafka, Prometheus, or maybe many others, right? Which need more than just a deployment and services, right? For example, database needs backup and restores, certificates needs renewal, monitoring system needs to update their configuration dynamically, right? So that it can place all those logs in a beautiful manner on that monitoring dashboard. So it need to collect all these things, right? So these are some stateful applications which we need more beyond than deployment and services. You can deploy it without operator. There is no worry, right? But if you remember, you need to deploy your CRD. Basis on that, you need to deploy your CR. You need to deploy maybe some cluster role. You need to bind that cluster role. You need to create some namespace maybe. Then you need a controller, your custom controller, which you can write in your Golang, right? Which we understood in our last video. But this is all a kind of operation overhead, right? You can do, right? There is no one to stopping you. But why to take an so much overhead being an admin, right? If we have the solution for all these called operators, right? So operator is nothing. Operator is a kind of custom controller that knows how to deploy and manage or maybe maintain a specific application throughout its life cycle inside your Kubernetes application. That's what we have mentioned, right? It is a kind of group which is already know, look, okay, how a CRD needs to be deployed. Basis on that CRD, what CR need to be deployed, what are other requirement, like we talked about the service account, cluster role binding, roles, right? So all these things, once an operator is installed, right, you can just manage apps like PostgreSQL, Prometheus, all these kind of like just pods and deployment, which we do for our stateless application. All right. So that's what we are doing here. Now, this is the concept we just talked about, right? There are few components of a operator. It's not nothing like you can just go and we need to understand the component before we deep dive into our demo part. So we have the CRDs that's we talk about, right? Which is just extending the Kubernetes API within the new resource, like MySQL cluster if you are doing, or maybe some certificate manager you are doing. And obviously, if you need to do all these things, then you need a custom controller. So custom controller is nothing, it is just watching all the changes to your CRs, right? And basis on that, it reacts. If I talk about from the basics, like it is just watching that what you have defined, what is your desired state and what is your current state. It will just match and perform tasks like creating pod, updating configuration, scaling, etc. Or if you are deleting anything, right? That who will take care? This custom controller will take care, and it will find out, okay, we have this desired state defined in the CR, but it is not matching the current states, and quickly it will spin up that particular thing, right? And the last part is the CR, obviously, where you just need to define, okay, what you need on top of that CR, because CRD is just extending the Kubernetes API. But using those API, what resource you can create, that is something you can deploy under the CR, right? What an operator can do, it deploy application automatically, handle upgrade and configuration changes. It is a self-healing, very like helpful feature which will restart your failed pod, reschedule your workload, right? It can perform the backup and the maintenance task as well. That's what it will do. Now the main part is how you can write your operator form framework, right? Because in the previous video we have seen that, okay, this is the something that CRD you can define. Basis on that CRD you can define your CR, and then you can define your custom controller, which you can run either as a direct uh, executable, or maybe you can deploy it as a deployment inside your Kubernetes cluster and you can run it, right? But if you want to deploy your or write your operator, right? So you can do a three-way. There is a website called, let me take you, this operator framework.io. So this will help you to write, you can build your operator from scratch, right? Here you can see how you can manage, how you can discover, or how you can build, right? What is an operator? If you want to understand, just go and read more about that. What is operator, how it can help you being a Kubernetes administrator, or what is the different capability it has. Okay. Now, if I come back to that build and operator part, so here you can see that there are three ways you can develop your own operator in the Go, Ansible, or Helm. Like whatever that you are familiar with, right? If you are good with Ansible, then you can just use Ansible SDK and you can develop your own operator, right? It is just the prerequisite. You just need to check what are all these, and then you can just simply you have that cluster admin privilege for your account so that you can do that stuff. Obviously, because operator is something which is running across the cluster and which must have the privilege to deploy your object, right? That is why. So here you can see that you need to install this operator SDK, additional prerequisite. These are the prerequisite, and you have up and running Kubernetes cluster, obviously. Then you can just create or maybe initialize the directory structure like this, and you can just simply initialize your operator. Like here we are doing in the example.com, and I'm using a plugin called Ansible. Then you can just simply create your API. We are not going to create a operator in this video, right? Because it is not to understand this operator, how it writes and all these things. Rather, what we will do is we will have a website called operatorhub.io, where we have kind of many operators are already there, which is managed by their respective communities, right? You can go and directly, let's say if you have a requirement for Prometheus, just search for the Prometheus. So you can see that we have the Prometheus operator is already there. You can go and you can just simply install this operator, and your monitoring stuff is up and running, right? You can just go, you can install these operator lifecycle, which is just nothing, which is just a kind of OLM operator, which will take care the entire lifecycle of create. And how you can create your operator, this is the main file. You, if you want to read more about on this, then you can go to this. You can download this YAML file and you can see that okay what it is doing. Then we have this cluster subversion, which is just downloading your operator and make it up. Apart from that, we have a different capability level for each operator, right? That is why that operator is more beneficial than the custom controller, because it handles many things. It can handle the basic installation of your custom controller and the application seamless upgrade, right? If you have that any update into your operator, you don't need to go and update. Whereas if you were using a custom controller, right? If you need to update, remember that we were just doing that uh, creating a different, what you call that, API for our this CRD, then we need to edit this and we need to deploy it. What if you have multiple CRDs, and if you have deployed these CRDs in a dedicated namespace, then you need to go, you need to track all these things and you need to update that. Maybe there is a chances, right? Because we are humans and we are maybe error prone. So we can, you may forget to update this, so that can hamper your Kubernetes or maybe your cluster and your deployment too, right? So that is where the operator will help you. If you have anything to update, you can just simply update your operator file and it will automatically get this. It will support the full life cycle, deep insight, autopilot. So all these you can just go through all these capabilities level, whatever you want to deploy. If you want to link more about on this, okay, what it is doing, then you can go to this repository and it will help you to understand, okay, what this is doing, Prometheus operator, how you can deploy it, what all these project status. So these are the very good information already there, and it is maintained by this community, right? You can see that it is already there. Maybe the command they you can the last week, some are 5 days ago. So all these are already there. You just need to just spend some time and you will be able to understand, okay, what exactly this operator is doing. Similarly, if you want to do, let's say you have that databases, right? I just remove it and I'll just go to database. Then you maybe you have the Cassandra, right? You have this Cockroach DB Helm, you have the etcd operator as well, you have the Postgres as well, right? You can just go through, you have MariaDB. So all are already before you jump into the operator, right? If you think that okay, I need to manage my application as a operator, so I would strongly recommend just check the operatorhub.io, which is a very good place. Maybe the requirement is already fulfilled by the respective community. You have that thing already up and running, right? So just go and check. If it is already there, you just need to check, download that operator and make it up, and you are good to go, right? But if it is not there, then I have already explained how you can write your own stuff. You can just follow this operator dot framework and you will have this all these things up and running. Okay, now let's come back to our document. So we were discussing this how you can write your operator, right? There are few mostly used operator: Prometheus, Elasticsearch, Istio, Argo CD. There are many things, right? And we have already seen that you can write your own, or already written and published can be downloaded from operatorhub.io. Controller can be written in Golang, Ansible, or using a Helm chart list of all YAML files. It is nothing, it's just a list of YAML files. Okay. Now, Golang support, because mostly it is in Golang. That is the mostly widely used language for the either you are trying to write your custom controller or you are trying to write your own operator. So Golang will be the most widely used. You can download your operator SDK, which is nothing. It is just a operator lifecycle manager, which will further install the operator and which will have all CR, CRDs with controller defined. Everything will be there, right? So what we will do is I will gonna take two demos, because initially I thought let's discuss only the cert manager, but recently I found that it is already kind of, you can see if I just go to the operatorhub.io. So this cert manager is they what they have done is they have deprecated it. Come on, I just need this. So here you can see that cert manager was deprecated, right? So that's what I have included another demo, right? That's the one thing. And the second thing is we will not use our own cluster here, right? Because I don't want to run all these things. So what we will do is you can do, right? There is no nothing which is stopping you. You can do, but I don't want to do it hodgepodge with my current cluster. So what I will do is I will gonna use this. Uh, there is nothing called. There is something called these. Playground, killer coda playground, okay, and we have that Kubernetes 1.3 for already there. Let me spin up. You just need to uh, authenticate yourself to your Google account or GitHub account, and you are good to go. And this is a 60-minute session you will get. This is we already discussed in our initial sessions where we discussed the lab setup, how you can set up your own lab for this, right? So here you have a 60-minute session where you can just get the additional tab also for the same server, and you can run all these. So I will follow my instructions, and then we'll see how we can deploy our own operator. So first, what you need to do is you need to install an OLM. In your OLM, you just need to deploy once, right? If you have multiple operators, you don't need to install it one again and again, right? So what I will do is I will just copy this, and I will go to my killer coda, and I will install this operator lifecycle manager. And here you can see that what it is doing is it is installing a CRDs, which is a custom resource definition. It is creating some namespace, it is creating some network policy, it is creating service account, then it is creating cluster role, binding that cluster role, maybe some OLM configuration, deployment, then again cluster role, operator group, and everything. So all these things you don't need to deploy your own. If you are using your own CRDs, right? So to make that CRD work so that it can do that work which you want, all these things you need to define yourself. So that is the benefit. If you are using an operator, then you don't need to do everything will be there, and whatever it is required, it will automatically create those all these things, right? So here you can see that it has installing a package manager, and now we are good to go. It is successfully rolled out. If you want to do, you can install the operator and wait for the port to be ready, right? Now let's install a cert manager port. I will just simply apply operator port hub. If you want to see, right, it is not something that which I have created. If you go to that any of the operator, because as of now we are dealing with the cert manager, so what you can do, you can just simply follow this, the same thing I am doing, right? Because it is at the one place, so that is why I am following this. Okay, now let's quickly create it, and it has created. Now what we can do is we can wait for those pod to come up. And you can see that one of the pod is getting initialized. Let me clear my screen, and I will just do it one more time. You can see that there is one pod is still initializing for this, and the catalog operator is already up and running since 2 minutes, and this pod is already completed its job. Right now we can just run it without watch, and you can see everything is up and running. The packages service is also up and running. Right now, if you want to see that, okay, what are the pod for the cert manager is up, then there is a different dedicated namespaces operator, and you can just simply check what you can see that cert manager, it's it's still getting created, but anyways we can watch. You can see that cert manager is already up, and there is one CA injector and the webhook, right? If you want to run more about on this, you can just follow the documentation. Okay, now there are something called cluster service version, which we need to wait, otherwise it will not work, right? So what we will do is we just need to see whether these CSVs are up and running or not, because that will help. If you just simply say k get operator, right, you can see it is already there, so maybe it was already initialized. Yes, that is the reason I can see that operator is right. So what you can do, you can see that we have many namespaces already there. Let me create a new namespace, k create hyphen n, and let's say test I have created. Uh, okay, it is this one. K create ns is created. Okay, now if I just want to see this operator, so if you just say k get operator, and if you want to see the test, you can see that it is automatically being deployed in this test namespace as well. So whenever you are what certificate manager does is it is just issuing a certificate with the self-signed from the certificate Kubernetes as a self-signed authority, right? So you just need to create a issuer. You can see as of now there is no issuer, there is no certificate, and there is no secret, right? But if you follow our document, so what it is saying is create an operator group in operator namespace which defines a set of namespace that an operator will watch and issue a certificate optional. So what it is saying is we can create our own operator group. If you just see kget oz hyphen n operator, or maybe it is in OLM, maybe. Yes. So you can see that it has already created a OLM operators in the OLM operator lifecycle management is in namespace. So what exactly it is saying is if you want that, okay, what all namespace must be managed by this, right? Maybe there are few test and development namespace. First you want to check your operator whether it is up and running, and then you want to roll it to the production. Then you can just set your target namespace. So what it will do is whenever you are updating your operator, so automatically that operator, that capability we have learned, right? It will automatically get the rolled out the new version towards these target namespace. But it is optional. You don't want to do, but it is for the additional granular level access if you want to deploy, then you can just think of it. But we will not gonna do that. What do we'll do is we will just create an issuer file. Issuer file is, you can see what it is doing is it is just creating that particular stuff. It is just creating a subscription towards this operator API, and this is the name of that particular issuer, and it is just using all this. So what I will do is this is an operator. I will just simply copy and I will go and I will say where it will enter this one, right? And I will go and I will just clear my screen, and I say cert.yaml, and I will just paste all this stuff, and k apply hyphen f cert.yaml. Warning, resource subscription my cert manager missing the kubectl last applied configuration annotation. Okay, because we used to apply, right? Obviously, but it has configured. So if I just say k get what we have done is we have created a this one, right? So what is that kind is subscription. If you just say k get subscription, you will see that okay, you have created your cert manager. If you just say k get what is that operators, right? This cert manager operator. Now these CSV needs to be fine. The same thing, if you just want to see this in, you can just search for this. And you can see it was already there up and running, because this file which we have done, right, this is something that we have already created with the help of this command. This is nothing, it is just simply doing this cert manager.yaml. So I forgot I have reapplied, but it's fine, it is already up and running, right? It just configured, it haven't created this. Now what we need to do is we just need to create this issuer.com. So what I will do, I will go and create a new file called issue.yaml, where what I want doing is I'm just saying create a issuer, and the name of that issuer is this one, and which is in namespace default, and it will automatically get self-signed this, right? So I will just create this key create f issuer, and now if I want to see, So earlier there was nothing, but now you can see that I have this. But if I just say k get certificate, as of now nothing. Now so far what we have done is we have defined our desired state. Like we are using a cert manager as an operator, and using that operator we are saying whenever there is a certificate requirement or the request from the any of the for any of the application, using this my self-signed issuer, it will create a self-signed certificate. Okay, I will show you how it will gonna do that. Now what it is saying is, now you have created now you need to create a certificate is called using this file 57.2. uh, okay, it is 3, there is a typo, let me fix it. And this one, so what it is doing is using that same my self-signed issuer, because that's what we have created, right? It is gonna create a certificate for my application called path4cloud.com, and it will g- bind that all certificate keys under the secret name called path4cloud TLS. Okay, let me just quickly create it and then I will show you. So here I will say path4cloud.com YAML, and let's paste your stuff and let's create it. It is created. Now if you see, you have this certificates is created, and this is the secret. If you go and you can check the kget secret, it is there. And if you just say path for cloud, this one get secret, and if you get this as a YAML output, you can see that this certificate is carrying my ca.crt, which we have already learned that this is the main certificate. Using this certificate, we are getting signing other certificate. This is the TLS certificate, and this is the TLS key for my application. Which application? Path for cloud dot application. So all these things you can do. If you want to capture, or if you want to like kind of provide all these information inside your certificate file, so that you don't need to configure it in later, so that also you can do, right? But here what I will show you, if let's say k get issuer, okay, k get secrets, fine, and k get certificate. Now my desired state is I want this certificate is to be ready, right? And this is the current state that it has to be mounted inside this certificate, path for cloud TLS. If I delete this certificate, remember we talked about the deployment, like when we are deleting our deployment, what it is doing is it is creating a new pod inside that deployment. Similarly, I have already defined it, so my operator is watching it continuously, and if I delete my secret, secret, and if I delete it, so k delete secret deleted from default namespace, it is deleted. But if you see, it has created it again. Earlier it was a 71 seconds ago, and now it is a 20 and if you just describe it, so you will get the same thing. It is path for cloud.tls. You can see it has all these files and all these stuff. So that is the benefit of the operator, right? Because the controller, custom controller is running behind the scene, and which will keep an eye for all these stuff. And whenever it is find, okay, there is a current situation is not matching the desired situation or the desired state, it will take an action and it will give you the stuff, right? The other stuff, if you want to do, right, let's say if you want to create a reader certificate which can read across all, so you can just uh, like kind of include all these other parameter inside your certificate. The thing is, you whatever the certificate you want, which we have seen already in our RBAC session, if you want there, what we were doing is we were manually signing that certificate, right? We were approving that K get CSR and then certificate approve that command we were shooting, and then we get the certificate. But here you don't need to do anything since we are using a cert manager as an operator. You just need to define your certificate file, whatever the requirement you have do, and using that issuer.yaml, what it will do is it will gonna self sign your certificate. That's what the benefit is, we get it. Okay, the second thing is we have something called okay, this we have seen, we have something called cube green. Okay, let me show you first on the portal what cube green operator is. Okay, now if I go to the home page and if I'll just search for Uh, cube green, yeah. So this is nothing. It will help you to manage your infra whenever you are not using, right? It will help you to kind of uh, to manage your infra when you don't want to use or whenever you are not using, right? It will shut down all these. So that is what it is doing. It is kind of the optimal solution for your infra. And if you see all these how you can deploy, so it you can see that it is creating a kind object called sleep info. I will explain you what it is does is, but it is again as a operator which will help you to shut down your resources when you don't need them. Maybe let's say you have a requirement, you are running some development pod, right? And you are working from 9 to 5. So what you can do is you can just set this operator on action. What it will do is it will make sure your pod is running on daily 9 and setting down at 5 so that you can save your cost as well, so that you can save your resources as well. And obviously you can just help the environment to make less footprint for the CO2 if you are using a cube green kind of operator. Okay, now let's come back to our document. This is my lab. Here I have already shown you how it works. So this is the cube green, because if you check the this one, right, so it is installing the same OLM which we have already done. This part we have already done. That's what I mentioned. You don't need to install this operator SDK again and again if you are using. You just need to install your required operator. So in this case, our operator is this one, and this is nothing, it is this file which will just again create a subscription to your my cube green, and it will create inside the operators, and it is using an alpha channel for this, and this is the name of your specification, and this is the source from where it will get. Okay, now let's quickly create it. Okay, if I just say k get pod hyphen n, if I just want to see, so it is still up and running, like coming up. You need to wait. If you want to see, you can wait and you can see that CSV as well. These already running because this is the related to which one? This is related to your operator life cycle. But if you want to see your this one, so okay, it is installing. So we need to wait to be completed, because this you can see that cube green is still getting installed. Okay, now it is up and running, succeeded, right? Now we are good to go. If you just say k get operators, so here you can say earlier we have the cert manager and now we have the cube green operator as well, right? This is up and running. We have already seen, and this is the CSV which we have already seen. It is up and running. Now we need to do that pod deployment, because I want to test this thing whether it is really setting down my thing or not. Okay, so it is asking us to deploy this file. So I will go quickly copy this pod deployment and I will copy, I will go, I will clear my screen and I will say pod.yaml and I will paste that stuff and I just simply create this k create hyphen f pod.yaml k get pods. So it is creating a 3 replica. Okay. Now let's come back to our document, what it is saying next. Then it is creating a sample application. That's what we have done. Create one more deployment to get this excluded from the operator. Yeah, there is one thing. If I'll just simply show you the file called 58-2, what it is doing is this is the main sleep info. Like we have the issuer and the certificate we have created for the cert manager operator. Similarly, for this operator, if you want to take an action, what you can do is you can define this syntax. It is the API version which we are using. The kind is the sleep info. Metadata is just to name of that particular that object you are creating this sleep info, right? And under the specification you have that property called exclude reference. Remember, we have taken an example of our deployment and maybe test and development and the production. You just want to uh, only the test and development infra or the ports to be down at specific time. You don't want to do it for that particular different stuff. So what you can do is you can exclude that deployment, whatever you want to exclude. Okay. And then you can define, okay, at what time you need to sleep, at what time you need to wake up, on how many days, 0 to 6 is Sunday to Saturday, and suspended cron jobs. If is there anything cron job is already done, then you can just need to suspend that. Right, and this is the time zone, in which time zone you can do it. If you are in not in correct time zone, you can set it using this command. All right, so that's what it is doing. And here it is saying if you want to exclude that particular stuff you don't want to, so what it is saying is you can create this deployment which we don't want to exclude in our. So here I would say prod.yaml. And when we create this sleep info, I don't want that that operator will bring my prod infra down. Okay. So let's come this up as well. It is up and running. We are good. So we have these ports are already up and running. Let me clear my screen. Now, what it is saying is now you can create your sleep information CR using this file. So let's go and copy this. I think there was a typo. It is 58.3. Let's copy this and I will just say sleep.yaml and I will simply paste it, right? And this is the time of 4:38. So what I will do is I will just simply say 04 and I would say 40 and make it up as 04:42. All right. And I will simply set this time zone because I am pretty sure we are not in the Asia. Okay. Let me quickly set the, and what I will do is I would say this one. Okay. I will just run one more thing, k get deployment. If you see, you have two deployment, and if I'll just quickly watch it, this one. So let me explain you what exactly it is going to do. We have deployed this file, right? We just change the time zone according to the current time. So what it will do is it will create a object called sleep info, which will create a kind of cron job, which is our next topic, which where I will explain you what is job and what is cron job and how you can set it, right? Which will create a cron job, which will schedule your pod to be down at this time and to make it up at this time. And if there is anything which you don't want to control via this operator, you can exclude that. So that's what we have done here. So you can see now we have set the time for 40. So what at 40, what will happen is for this Web3, this deployment will bring down at that particular time, right? Let me show you the time now. If I see, so this is the time now, 4:40, this one. And we have, uh, okay, it will be suit now because let me see what time we have given in this sleep info.yml, and it is saying that, okay, it must be sleep at 4:40. So we need to just wait and it will bring it down at this point. And then again, it will wake it up at 4:42. Okay, I think we forgot to create this sleep info. So what I have done is I have edited this and I have created it again. So now if you see, it is created just 10 seconds ago. And probably I have set the time as 4:43 now. You can see that it is yet to 4:43, and at 4:43 what I was, you can see that it was already there or with the 4:42. It has terminated all the pods. If you just see, we have only prod app is running, right? It was so fast. Now, at the time of what is the time we have? 4:44. Okay. What it will do is it will gonna spin this pod again because that's what the time we have set as wake up at 4:44. Okay, so let's wait and see if it is giving me, because as of now you can see that only the prod app deployment is running, and that's what, why, because we have excluded this deployment, right? That's what the deployment we have done, prod app, and it has brought down from 3 replicas to the 0 replica. That's what, that you can save your cost, you can save your resources, right? That is the benefit of this cube. Okay, it is time, so I just, you can see that, right? Now it is, because the time is already there, right? We just ran 4 seconds ago, now it is 8 seconds already passed, and we have our both replica up and running. You can see the pod is also get up and running. Again, when the next morning, this time the pod will get down, and this time the pod will come up, right? So that was the kind of this operator, like how it works, because what it is doing, right, under the hood, operator continuously watching any changes in the custom resource or the Kubernetes API, whatever you are doing, right? It observe the current state, compare it with the desired state, and if it is not getting that, what it do, it will simply reconcile those state and take action to match that particular requirement, right? Now uh, I think that's it for the day. To summarize, operator reduce your manual operation, like whatever we have deployed using our operator, you don't need to do and worry about all these things. It will bring the reliability and the consistency because you need to update only at one place. It automates complex tasks like upgrade, scaling, failover, everything it will get automatic, right? And it is well integrated natively with the Kubernetes. That's what we have seen, that it is operator.hub.io. They are doing it, right? So that was a quick overview of the Kubernetes operator. I hope that found or maybe it was helpful you to explain what operator is, how it exactly works, and all these things. All right. So in next video, we will gonna discuss what is the jobs and cron jobs, how you can set, and what are the benefit of those. All right. So I will take leave from today. And if you found this helpful, then don't forget to like, subscribe, and drop a comment if you want me to cover a specific operator, right? Maybe Prometheus or the PostgreSQL. Otherwise, we have understood how a operator works and what is the benefit of the operators. All right, guys. So stay happy and stay learning. I will meet you in the next video. Thank you. Bye bye.